the second part of 2.4. Again, we're still more about linear equations, and really we're going to continue on with point slope form. So we have to, again, remember the formula of y1 or y minus y1. Come on now. Y minus y1 equals m times x minus x1. Really, we're just looking at different ways that I can give you this m. And last class, we had a couple of problems where m was flat out given to us. It said m equals, and then we had a couple of problems where were given 2 points and we had to find the slope first before we could do a couple of problems. Well, now we're going to give you the slope in terms of knowing that parallel lines have the same slope and perpendicular lines have what are called opposite reciprocal slopes. So again, literally, it's the same exact slope. So these two lines will have the same slope but a different y-intercept. For perpendicular lines, they will have opposite reciprocal. So there's two things we have to know there. Number one, perpendicular lines opposite means if the given slope is positive, the opposite is negative. And it's reciprocal. So you have to flip the fraction. Even if it's not written as a fraction, say the slope was 3, the reciprocal of that would be 1 over 3. So we have to make sure that we know those two facts. Parallel lines have the same slope. Perpendicular lines have what are called opposite reciprocal. Okay, opposite and reciprocal slopes. Okay, so let's take a look at a couple of examples here. What is the equation of the line in slope-intercept form of the line parallel to y equals 6x minus 2 through 1, comma, negative 3? So right here, the whole reason that this is given to us is so that I can say m equals. And because it's parallel, it's the same slope. So m is equal to 6. And it goes through the point 1, negative 3. So now this is exactly like the type of problem that we did last class. Okay, plugging it into point slope form. Why? I'm not going to put minus a negative now. I'm going to hope that we're getting used to this, that negative turns this negative 3 into a plus 3 equals 6 times x minus 1. Okay, again, why is this a positive? Because I plugged in a negative 3 and it changed the sign. So then now what are the two steps to getting y by itself? I'm going to distribute. So 6x, 6 times negative 1 is minus 6. Then I'm going to subtract 3 from both sides, and I get y is equal to positive 6x minus 9. Again, notice this is the new equation that goes through 1, negative 3, and it has the same slope but different y-intercepts. Okay, so part B, this example, the perpendicular to y equals negative 4x plus 2 over 3. I really like the way this problem is written because this is my y-intercept. This has nothing to do with the slope. So what is the slope that's given? Slope is negative 4. Well, if I write it like this, it's really easy to see that the opposite reciprocal of a perpendicular line to negative 4 over 1 would be opposite is positive, and then the reciprocal would be 1 over 4. Then it goes to the point 8 comma 5. So again, plugging it into the formula, y minus y1 equals m times x minus x1. I got y minus 5 is equal to 1 over 4, and that's positive because it's the opposite reciprocal of x minus 8. And then the two steps to getting y by itself are to distribute. So y minus 5 is equal to 1 over 4x minus 1 over 4 times 8 is 2. So I have y minus 5 equals 1 over 4x minus 2. I'm going to add 5, and I get y is equal to 1 over 4x plus 3. And again, if you plug that into Desmos, you would see that the lines are perpendicular, and this would indeed go through the ordered pair 8 comma 5. So again, we're just looking at these. We're using point slope form, and I'm giving you different ways that we can give you slope. So if I tell you the lines are parallel, it's the same slope. If I tell you they're perpendicular, it's opposite reciprocal. So I really like these next couple of problems that I'm going to give you. And honestly, there's no work to do. These problems are really simple. It says, write the equation of a line. This is the symbol for perpendicular. This means perpendicular to. Okay. So that just means perpendicular to y equals 4 and goes through negative 10, 6. Well, What does the line y equals 4 look like? Y equals 4 is a horizontal line that looks just like this, right? So what would a perpendicular line to a horizontal line be? It would be a vertical line. So I'm looking for the vertical line that goes through the ordered pair -10, 6. And what is the equation of a vertical line? It's x equals, and it's going to be x equal to whatever the x value is of the given ordered pair. So no work to do there. It's more of an understanding problem. The answer to that is x equals -10. Again, a perpendicular line up to a horizontal will go through at -10. So it look like this and go straight up and down. That's a really bad vertical line. Let me do another one. Okay. We'll go straight up and down through this point. Okay. Running right along there. And if that line extended, see, it would form a nice 90 degree. So the answer to that is x equals -10. And likewise, m equals 0 goes through -2, 5. Well, what kind of line has a slope of 0? That would be a horizontal line. And a horizontal line is always the equation y equals. And then now, what's the y value that I want it to go through? 5. So it would just be y equals 5. So again, these problems can look confusing, and there's no work to do. I'm not plugging it into a formula here. These are, do you know what slope of 0 means? What type of line has slope of 0? And can you write the equation of that line? So here's a couple of problems from Delta Math. It says graph a line that is perpendicular to the given line. So they want you to actually physically graph a line. So you'll have the click and drag plot perpendicular line. I don't have that. So I'm just going to, again, draw one in here. Okay, and what's the slope of this line? Well, it looks like it goes up one, right one, up one, right one. So the given slope is m equals 1 over 1. So what would the perpendicular slope be? Well, it's the opposite. So it'd be a -1 over 1 because I'd flip it. So down one, right one, down one, right one, down one, right one. And a perpendicular line. And again, my line's not going to be very straight. Okay. But, oof, that's really bad. Sorry, my pen is not working the way it should. Okay, so again, in connecting these dots, I got a nice perpendicular line that looks like this, and the slope of this is a -1 because it's the opposite reciprocal. So the original slope was 1 of the given line. How did I get that? Because I counted up 1, right 1, and I could keep doing that. Up 1, right 1, up 1, right 1, and that's the slope. Well, what's the perpendicular slope? It'd be -1. And again, if you write that as a fraction, it's 1 over 1 and -1 over 1. So there's a couple problems like that. Again, just finding the slope and writing the opposite. And if it were to write a parallel line of this, well, then the slope would be 1, and I would go up 1, right 1 to graph a line that's parallel to it. Okay, right? Which equation represents a line that is parallel to the given line? So we talked about this yesterday. I have to get y by itself here. I can't tell what the slope is just by looking at this. So I would subtract x from both sides. It would give me -5y equals -x minus 25. I would divide by -5. Okay. And I want to make sure you know how to write this. Y equals, what is the number in front of this x when you don't see it? It's a 1. So it's a 1 over 5x. Notice a negative divided by a negative is a positive. Okay. So what is the equation that is parallel? Parallel means same slope. What's the slope? M equals 1 over 5. So any line here that has a positive 1 over 5 would be a line that's parallel to. And that, of course, is that right there. Okay. So again, looking at these problems, make sure that you do the Delta Math assignment. Hopefully we know after today how to do point slope form and the effect that a parallel and perpendicular line have on the equation. Have a great day.